Great, so this is question 2.4, and this is called partition. And what we want to do is write code to partition a given linked list around a value x. So in this example, we have a linked list here, and we want to partition it around the given value 5. So x is equal to 5. And so you can kind of see in our output that what happens here is that all of the values on the right side of our list are greater than or equal to 5. So we've kind of iterated through this list, and all of the values that are greater than or equal to our partition number is on the right side. And on the left side, you can see that all the values that are less than 5 now appear on the left side of the list. And so we've iterated through here, and we've appended all the values that are less than 5 on the left side, and all the values that are greater or equal to 5 are on the right side. So you can kind of see that partition around this, test case here. So what I did is, you can just see I've created these 7 different nodes and gave them the same values in this example, and then I've linked these nodes together. And this is just making use of that node class she provided in the book, where we pass in the data or the value that's stored in our node, as well as a pointer to the next node. So then we just call the method called partition that we're going to make today, and then we just have display code here, so we just iterate through our list just to debug and print the final result of our code. So what we're actually going to do is we're going to have 2 pointers. One of them is going to be called head, which will be pointed to the node that's passed into our method here, and that's just going to be node 1, which is the first node in our list, or the head node. And then we're also going to have another node called tail, and that's also just going to be pointing to the first node in our list. And then, like most kind of typical linked list questions, we will iterate through a list until we hit the end, or until the node is equal to null. And then at the very end, we're just going to return our head node, just so that we can kind of iterate through a list and display it. So before we kind of implement all the logic for our algorithm, I'm just going to quickly kind of show you a whiteboard, just so you can kind of have a good understanding visually of what we're going to implement before we just write out all the code. So here is our list that I just kind of described before, and we have the number 3 here, which is the first node in our list. And so remember, we have those kind of 2 pointers here. We have the head pointer, we have the tail pointer. And so what we're going to do is, as we're iterating through this list, we're going to be appending these values to the tail and to the head. And we decide whether it's going to the tail end, which is to the right, or to the head end, which is to the left, depending on if they're greater or less than our partition number. So our partition number, if you remember, is 5. And so we start with the number 3, and we see the value 5. And so that is actually equal to 5, so we're going to push it on the tail end. So we actually put it here, and we have our tail pointer and head pointer, just to step back here. So originally the head pointer is pointed to 3, and our tail pointer is pointed to 3 as well. But then when we add 5 to the right, we're going to move this pointer to be pointing here to 5. So now we increment to 8, and that is greater than 5, so we push it to our tail, and then we move our tail pointer to 8 here. And the tail pointer, this thing here, is once again this variable. And so now we encounter the number 5 again, which is equal to 5, so that goes to our tail end. So we set it here. Then we move our tail pointer one more time. We now increment to 10, which also goes here. And then we move that tail pointer one more time. Right, so our tail pointer is now pointed here. So now we encounter 2, which is less than 5. So we're actually going to set it at the head of our node here and move this head pointer to the start of our linked list. And now we encounter the number 1, which goes here. And so we're going to move this pointer to point to that value. And now we've incremented through the whole linked list. We've reached null here. I can't spell it out. Null. And so that's when we finish. And then we're just going to return the pointer to this first node so that we can, display our linked list. So we're going to go ahead and implement that. So one thing that we're going to need actually is we're going to be messing with our current node because it's going to be moving around some. So we're going to call a temporary variable called next. We're going to set it equal to the next node. So after all of our logic, we're then going to set our node equal to next. Great. So what we do is we just say if our node dot data, because that's what we specified here, if our node dot data is greater than or equal to our partition number, so which is 5, we are then going to add it to our tail end, right? Add to tail end. So it's greater than or equal to 5, so we're going to add it to our tail end. So our tail is going to be, or our tail dot next is going to be equal to the current node, and then the tail is going to be set to that node. So otherwise, then the value is less than 5 or less than x, our partition number, so we are going to add it to the head end, which is this left hand side here. So we're going to do the same thing where we then do our head dot, or our head will be then equal to the current node, and our node dot next, here we want to set our current node dot next equal to the head of our list. So say when we're inserting 2 here, we're pulling it from here, we're going to say 2.next is equal to 3, and then we're going to be setting this pointer to be pointing to this new head here to 2. Great. So let's just add that. So our head is now equal to the current node. And that's it. So we're iterating through the list, and you can see why we need to add this temporary variable, because we're modifying, what the node is being set to, so we really need to store this next value. So why don't we go ahead and print it. Oh, and that's just because I believe I forgot to set that the tail is then equal to tail.next is equal to null. There. So then we just kind of look at what our expected output should be. So it goes 1, then 2, then 3, then 5, then 8, then 5, then 10. So we successfully partitioned our linked list, and the time complexity for this is O of n, because we're just iterating through our list just that one time. And our space complexity is just O of 1, because we're not really using any extra data structures. We're just using these 2 additional pointers just to iterate through our linked list. So great. I hope that helped, and good luck with the rest of your algorithms. Thanks.